Alright, now we are going to run through defining operations, defining CAM features, so that way we can manufacture this part. Um, if you have not set up your 3D model here in SolidWorks for the CAM process, there is another video covering that. That's assuming if your part is similar to this, where you are unable to physically hold the boundaries of your part in a vise. This part, we defined a flat stock in which we'll clamp straight to the CNC table and kind of route out our part. So there's another video covering how to do that. For now, we're going to jump straight into the CAM tab, and we're going to start by defining the machine that we would like to use. If you have not already imported your technology database, which will define your machine's tool cribs, post-processors, there is another video covering that. So we're going to be using the Milltronic CNC for this part. Due to its larger travel, fall students, that's the one in the ID lab. So we're going to go ahead and highlight that, hit select. You can ignore this post-processor error for now. That's not important right now. For the tool crib, if you already have a tool crib, you can select it down here. If you have not done so already and you'd like to make a new one, you can highlight the default Milltronics tool crib or any regular empty tool crib for that matter. We're just going to highlight the Milltronics. We're going to highlight all of our tools and remove them. That way the tool crib is empty. This does not overwrite the default. We will save this as a copy. If you have not made a technical drawing for your part, I would advise you pause the video, go do that. Define the tools that you're going to need, what your diameters of your holes are, and make a tool crib list similar to this that you can print off, take to the machine with you, have next to you on the computer. This is going to expedite us defining our tool cribs and our tools. So the first tool we're going to need is going to be a 1/4 inch flat end mill. So we're going to go ahead, add that tool. So we're going to go to tool type, flat end mill, and then we're going to scroll down until you find 1/4 inch. The 3 flute is going to be closest to a 4 flute. The flute count does not matter because our feeds and speeds will be defined manually, so we can ignore that for now. The next tool we would like to add is going to be a number 7 machine drill with a diameter 2010. So we can go to drill, sort by diameter, and here's our number 7. Next drill is so we're going to add our 60-degree center drill. So add tool, center drill, and the number 3. Technically a little out of order, but that's okay. Then our number 21 for our tapped number 10 holes up here. So that'll be 158 will be the next size down. Here's our number 21. And then our edge finder does not need to be defined in the tool crib. No CNC process will be using the edge finder. This is simply so that you know station 5 on the control panel will be for our edge finder, and our defined contact diameter is here. So once you have the tool crib set, you can save this tool crib as a copy. As long as you don't save it as the same name, it won't override anything, and we will save this as the test tool crib. Once you've gone ahead and selected that, you can hit OK down here, and you're ready to start defining operations. Well, kind of. So first we're going to select that coordinate system we made in a previous video. So that'll be coordinate system 2 right here. So SolidWorks coordinate system, make sure that this is and there you go, coordinate system 2. Hit check there. Stock manager. If your stock is pre-made, being held in a vise, the stock type will just be your part boundary. However, that's not the case here because we're going to be routing out the perimeter of this part. So we're going to use the sketch we made in a previous video and define that as an extruded sketch as our stock. Just make sure that your stock is heading in the correct direction. You can see how it encapsulates the part here, and that our Z is touching off the top just as it will on the CNC machine. Material here at this point does not matter. We will be overriding feeds and speeds manually for every operation here. And then the thickness of your stock can be specified down here. So 1/4 inch polycarb is what we're running with. Lastly, you can define the mill setup and select the face in which you're going to mill down into. And you're ready to start defining operations. Now, for simple parts, the extract machinable features function may be tempting and may very possibly work. However, I find that it either defines the feature incorrectly or chooses a poor and inefficient route to machine. So we're just going to run through doing that manually. So we're going to right click on our mill part setup. Keep in mind, we should only have one of these. We're only machining into one face. So we are going to specify a 2.5 axis feature. We're going to start with our holes here, here, and hole diameter here does not matter. You can select all your holes. It will sort by size automatically, assuming all these holes go the same distance. And we are drilling these holes all the way through the part, so 1/4 inch down. You can see here it stops right at the bottom of our part. We can go ahead and hit check, and we have 2 hole groups and 1 center hole here. Next, we're going to define the final feature, which will be the actual part that we'd like to cut out, and that's going to be a part perimeter feature. It's going to be a boss, and it's just the perimeter of the part and the top 2 edges. That's it. So now we can jump into defining operations. We can right click here on mill part setup, and we'll start with drilling all of our holes first. So we're going to go ahead and center drill using our number 3. And we do not need to center drill this large hole. We're not going to use a drill to drill that out. We're going to route that out, kind of spiral contour that down with an end mill. So we're just going to define these 2 hole groups here. Hit check. It will open up a operation parameters window here. Once that's open, there's a few things you need to do off the bat. If you go to center drill, we can spot drill. Our dwell time can be 0. There's no reason to dwell right now. Our rapid plane is the top of stock. If for whatever reason you're clamping, you have screws, you got some reason this needs to be higher than 1 inch, this is where you can override that. Otherwise, we're going to go to feature options. We have 2 hole groups. We're going to override machining depth, and we're going to say 1/8 of an inch. We want to make sure that the diameter the center drill creates is not larger than the final hole size here. Otherwise, we're going to get a countersink where we don't want one. We're going to do that for both hole groups here. Once that's done, we can go ahead and hit OK. And we have feature 1 defined. At any point, you can hit generate toolpath, simulate toolpath, and we can slow that way down. You can double check that we center drill and we don't blow past our hole diameter. Next, we're going to actually drill those holes, so we'll come back to our mill part setup. Again, there should only be one of these. We're only machining into one face. We're going to go to 2.5 axis mill operations. We're going to go to hole machining, and we're going to actually drill. So let's start with our number 7, tool 2. We're going to start with not hole group 2, hole group 1. Hit check. And right away it's going to pull up your operation parameter. Once again, we want to make sure that under hole parameters we're going to be pecking here. Feeds and speeds look fine, 2000 RPM. Now because this will be sitting on top of a sacrificial board, or you should, if you're holding this in a CNC vise, you should have clearance underneath your stock. We're going to add the tip length to make sure that we actually drill a clean hole all the way through the part, and we don't drill the tip of the angle drill tip to our 1/4 inch dimension. We can hit OK there, and once again we can generate the toolpath, simulate, and make sure that it's behaving as we expected. And we are all the way through, we're ready to go. We'll do that exact same thing for the number 20, the 159 hole, the tap drill for the number 10 screw. So we'll define our tool here, features, the hole group we'd like to do. It's going to open up the operation parameters page, come over to feature options, add your tip length, and hit OK. Last hole we got to do is this larger hole with a diameter of 0.875. Not something you would realistically want to drill out with a drill bit or a hole saw. So we're going to interpolate and spiral down that with an end mill. So we're going to come over here to mill part setup. We're going to do a hole machine operation, and we're going to do a contour mill. We're going to specify the 1/4 inch flat end mill from our tool crib and hole number 1. Now that we're using an end mill, we're getting into the territory of feeds and speeds. I use an app called FS Wizard. It's great for kind of defining feeds and speeds at specific RPM for specific materials. So we are machining in a soft non-metal, it's a plastic. We're going to be assuming that our cutter is at a 100% width of cut, and we're just going to specify a 6 or 4 thou depth, or 4.04 depth of cut. Sorry, my bad. There's a problem. So go ahead, specify your end mill diameter. Our depth of cut can be 60 thou. We have a 3-flute end mill, stick out, type, coating, all that. So we have 6 thou depth of cut, 100% width of cut, and it's telling us 36 inches a minute at 2000 RPM. So we can come over to our operation parameter, start from the edge. So we got tool, all of this should look good, number of flutes, overall length, your mill holder, tool crib, station, all of this should just come in correctly. Under feeds and speeds, we're going to define this by operation. Spindle speed will be 2000 RPM. Our X and Y feed rate we said was 36, and we can leave our Z as 25% of that and our lead-in as 75% of that. Now we're going to go over to contour. We're going to be climb milling since we're on a CNC machine, and we will be defining our depth as decimal values instead of percents of our tool diameter. So our first cut amount, since we are going to be interpolating down, is going to be that 6 thou depth, or 60 thou. And we are going to set our ramp value as the cut amount, which means that every revolution this makes, it's going to be moving down 60 thou. Cleanup pass we can leave, we're going to be contouring. Come over to NC, make sure that CNC compensation is disabled, but toolpath center compensation is enabled. And then once again, you can define your rapid plane, your clearance plane. Since we are going to be plunging down into this hole and interpolating, we can come over to lead-in, disable gouge check, and disable lead-in. That way we don't return an error that there's no safe lead-in value. If you wanted to ensure there was some safe lead-in, you'd have to use a smaller end mill, but we're not too concerned about that. Once again, we can generate toolpath. If we want to simulate just this toolpath here, instead of running through the entire list, we can right click on it, simulate toolpath, and we can watch our end mill come down and interpolate, spiral down, and cut out that final hole diameter, leaving just a small chunk in the center for it to be discarded. Alright, now that you have done all of the features that are on your part, it's time to cut out the part. So we have everything ready to go. We have our stock boundary, we have all of our features cut. So we're going to come over to mill part setup, and we will do our first 2.5 axis mill operation. And rather than roughing out everything out of our stock, we're just going to route out with a contour mill operation. We're going to pick that 1/4 inch end mill, and we are going to do the part perimeter. We're going to open that up. If we go back to FS Wizard, specify our depth of cut as half our stock thickness, so we can do this in 2 passes. We can see that had relatively no effect on our feed rate, so we're going to keep it at 36 inches a minute. We will leave our lead-in as it is, come over to contour. We're going to set our cut amount as an 1/8 inch, and our final cut amount is 0. So that means because this is half our stock thickness, it'll do this in 2 passes. NC, disable CNC compensation. Feeds and speeds, define this by our operation, and we can do 36 inches a minute. We can leave our Z and lead in as the current percents. Now, because our feature is defined as a part perimeter feature here, we can do something a little fancy. So when this cuts out our part, we can simulate that actually. So as we cut through our part, when we get to the end, we are going to start to remove the part from the stock. And if you remember correctly, we are clamping the stock here and here, but we're not actually clamping the part. So it's going to get to the end, it's going to vibrate, it's going to rattle, it's going to throw it across the mill, and we will not have a clean cut. So there are 2 options. If you're clamping this on top of a sacrificial board and you're not holding this in the vise, you can screw the part directly to that sacrificial board using the holes you drilled in an earlier operation. Just free holding the machine, throwing some wood screws in there, and sending it on its way. However, because we defined this as a perimeter boss instead of just a regular pocket or something like that, we can edit the definition of that contour mill. We can come over to contour, and we can do tab cutting, which is going to leave little tabs that connect our part to the stock that we defined earlier and hold it in place, and then you can cut those with a pair of side cutters or a grinder or whatever you want, depending on your material. So we're going to want to define the length of our tab and the thickness of our tab. So I'm going to leave the thickness as half the material thickness. 1/8 inch polycarb isn't too much for a cutter to get through, but is enough to hold the part in place. And these really don't need to be much bigger than, say, 3/8 of an inch. Next, we're going to define how many we want, and we can kind of just increase that till it looks good. This looks good. We have 4 tabs holding it in good places. You could increase it to 5 if you'd like, but I like how this is holding it pretty much on every edge. can kind of mess with thickness, see what looks good to you. I like the 3/8, that looks fine. We can hit OK, and then we can resimulate that toolpath. We already know what this looks like, so we can blast through that. And you can see we left nice little easy to cut tabs joining our part to the stock. We don't have to mess around with screws. We can just let the CNC do its job. There you go. So that is the entire part cammed out. There will be a separate video for post-processing, specifically for Sheboygan Falls students and the Milltronics mill.